Hello, grade 8. Our physics lesson today is about work. Work of a force. A train toy is pulled forward by a force F parallel to the rails and moved to the right, as shown in document 1. This force is along the motion of the train. It therefore performs work along its displacement between points A and B. The work W done of a force F parallel and in the same direction of displacement d is as great as the force is bigger and/or the travel distance is longer. Work done is equal to the magnitude of the force times the distance. In SI units, work is expressed in joule, F in Newton, and D in meter. A block is subjected to the action of several forces during its motion between A and B, as shown in document 2. Force F performs work since it partakes in the motion of the block. F is parallel to the displacement. The weight and the reaction of the support do not perform any work during the motion of the block because they do not partake in the motion. Weight and the reaction of the support are perpendicular to the motion. A force applied to an object performs work if this force is not perpendicular to the motion of this object. In document 2, the magnitude of force F is F equals 12 newtons. Calculate the work done by this force when the train moves 2 meters. Work is equal to the magnitude of the force times distance. So it's equal to 12 times 2 equals 24 joules. Work done by gravity. A ball falls vertically from point A to point B, which is located on the ground as shown in document 3. In this case, F is the weight of the ball. So, weight F is parallel to the motion in this case. Therefore, weight performs work during the fall of the ball. Work is equal to the magnitude of the force times the distance. In this case, the distance is equal to the height. Work is equal to the magnitude of the weight. We already know that the magnitude of the weight is equal to mass times gravity. So work is equal to mass times gravity times height. Motive work and resistive work. Work done by a force that facilitates motion is known as motive work. A crane lifts a load up of a building by means of a vertical cable as shown in document 4. Tension is in the same direction as motion. This tension facilitates the motion of the load. The work of this tension is said to be motive because it has the same direction as the motion and therefore facilitates it. The weight of the load has a direction opposite to motion. Weight resists the motion of the load. Weight does resistive work. The work done by a force in the same direction as displacement is said to be motive since it facilitates the motion of the body. The work done by a force in a direction opposite to that of displacement is said to be resistive since it resists the motion of the body. Power of a force. If two different systems perform the same work, the most powerful is the fastest. In other words, the one that is capable of doing the same work in a shorter time is faster than the other. Karim and Sami lift the same load of 10 kilograms for the same displacement of 200 centimeters at a constant speed each, as shown in document 5. The same work is done by Karim and Sami because they are lifting the same load using the same motion. Knowing that the magnitude of force F exerted by each of them is equal to that of the weight of the load to be lifted up, the magnitude of F is equal to the magnitude of the weight, which is equal to mass times gravity. equals 100 newtons. Therefore, work is equal to the magnitude of the force times d, which is equal to 100 times 2 equals 200 joules, since 200 centimeters is equal to 2 meters. Karim is the fastest because he performs the same work in a shorter duration. The work done by each person in 1 second is 200 divided by 4 equals 50 joules per second for Karim, and 200 divided by 8 equals 25 joules per second for Sami. Karim is the most powerful because he performs a work of 50 joules per second, knowing that Sami performs a work of 25 joules per second. The power of a force is the work done by this force during a unit of time. Power of a force is equal to the work over the time. In SI unit, the power is expressed in watts, W, work in joules, J, and time in seconds, S. A force applied to a body performs a work when it is along the motion of this body. The work done by a force parallel and in the same direction as displacement is given by the formula work is equal to the magnitude of the force times the distance. A force perpendicular to the motion has no work. Motive and resistive work. If a force in the same direction of motion facilitates the motion of the object, its work is said to be motive. If a force in a direction opposite to that of motion resists the motion of the object, its work is said to be resistive. Power of a force. The power of a force is the work done by this force during a unit time. It indicates the speed of doing the work. The power of a force is given by the formula power is equal to work over delta T. Thank you. That's it for now.